So we've got one last thing to do before we can rig. I've got this custom curve window right here, and this is my offset parent matrix script. You may have a similar one, but I'm going to upload this one so that you have it. It's a little more advanced than the one I had you write, but very similar. So I'm going to give this to you so that we'll all have the same thing and we can all work together. But before we really get into rigging, the one last thing that I want to do is talk a little bit about how to make one object control another object, because at some point we're going to have a skeleton and we're going to have a whole bunch of curves. I'm going to make a box and a bunch of circles, and what we're going to want is for the curves to control the joints. So it would be really good if before we went any further we talked about different things that you can do to have things control other things. You'll also note that I'm in my rigging workspace, which, as you know, I don't really like, but I'm in here so that I can talk about the node editor and show you things with the node editor. When I start the actual rig, I will move back out of this workspace. So the first thing, I'm just going to clean this out. The first way to have objects control other objects is one that you already know. I can make one object into the parent of another object. So I can take this circle and make it the child of this box. Now anytime I move the box, the circle will move. If I open this up, there's the circle, it moves by itself, but the parent will always control the child. Now, nothing happened down here because I already cleared this out, but if I take these two and I add them to the graph, you'll see that it really looks like there is nothing connecting them. There's not a single thing, and even if I add another one of the circles, or let's just do a 4-arrow, here's my new 4-arrow curve. If I make that the child of the box, again, nothing happens down here. That means that this is a very computationally easy thing for the computer to do. So that's great, and it's simple, and you already know how to do it. There are only a couple of minor setbacks with this. The first is that the child will always inherit the transforms of the parent. So if I take this box and I move it, I rotate it, and I scale it, now it's got all of this information over here in the channel box. None of the circles do, they're all completely clean, but when I make this circle into the child of the box, you'll see that it inherits all of this information, and that is because it is now existent relationally to the box. So even though this is still at the origin, it believes itself to have inherited all of its parents' information, and although they move together, they rotate together, they scale together, the circle will now contain all of this extraneous information that it got from the parent-child relationship. There are a couple of ways around this. The first one is that I can always make a group node. If I deselect everything and I press Ctrl G, that creates a group node. The group node is known as a null object. When I make a null object, what I'm putting in is a barrier between two objects. So my box is still all rotated. I can make my null the child of the box, and now it inherits all of the transforms, and now my circle maintains its current origin because this null object is holding all of the transform information for it. So that does get confusing, but group nodes are great because they put a buffer node between the parent's location and the child's location so that everybody can kind of maintain their relative position without interfering with their actual data. So that's problem one. Problem one is that I really need to have a step in between the box and the circle in order to maintain my relative position information. Problem number two is that frequently there are already pre-existing parent-child relationships. So if I take another one of these circles and I move it over to one of these joints, I'm going to freeze transformations on it so it believes that it is at the origin. And now I've got this joint here. If I want the circle to control this joint, I can do that. Let me open this up. I'll take joint 3, and you are NURB circle 2. So I'll just middle mouse drag like so, and now my joint is indeed the child of my circle. The problem with this is that it breaks the existing parent-child relationship, so it gets rid of this bone here, because now the joint is the child of the circle instead of the child of the previous joint. And that can do some bad things to my joint orientation and my joint's relative position information that it already had. So I don't really want to start making parent-child relationships between my joints and my curves, but the parent-child relationship is one that I have to mention as a way for objects to control other objects. It's not the only way. The next way, let me clear my graph again. I've got this perfectly nice circle right here. I've got this joint right here. I'm going to add them both. Now I've got my circle and my joint. If I wanted to, let's say, have the rotation of this circle control the rotation of this joint, I can click on the circle, take its rotate out, we'll just do all three of them, pull that over here to this circle, and go to rotate in. And now, if I take this circle and I rotate it, you'll see that that will control the joint. That creates a single connection between these two objects, which makes it a tiny, tiny bit more computationally expensive than a parent-child relationship, but it's still pretty easy. And it works pretty well. Of course, if I wanted to do more than just rotate, if I wanted to go back and translate, I would have to go back and go through this whole process again. And you would see that now the joint actually moves because the circle has a 0 location, and that is the joint's 0 location. So this method is a little more complex than a parent-child relationship, which already had complexity to it, but it's cheap and easy for the computer to calculate. The third method is the newest method for all of you, and that is to work with this menu over here called Constraint. A constraint will create a secondary object between the two things that I'm working with, so in this case the circle and the joint. The secondary object, called a constraint node, will perform a variety of actions. So let me go ahead, we'll start with the parent constraint. The parent constraint, if I look at it in the option box, will do two things. It will constrain translation and rotation. Selection order does matter. I want to select the control object first and the thing to be controlled second. The thing that I say generally is that the constraint is placed on the active object. The active object is this green color when selected. So the parent constraint does translation and rotation. If I hit apply, you'll see that in my node editor that makes a super duper complicated little graph with arrows that run in all of the directions at the same time. So this is the most computationally expensive method, but you'll note that the joint stayed in place, the curve is right here, I can rotate, I can translate. So in terms of user effectiveness, it's very high. So again, if this were a 15-week rigging class, I would probably be trying to cut down on the number of constraints that I was using to keep the rig more efficient. But this is a 3-week rigging exercise. We're going to be using constraints to make our lives easier. The three basic types of constraints that we may be using are the parent constraint, which controls both translation and rotation, the point constraint, which constrains translation, and the orient constraint, which constrains rotation. They all function basically the same way. You'll run them through the option box. We're going to work with maintain offset checked for the duration of this lesson. And then you can just either add to run the command and close the window, or apply to run the command and keep the window open. So that's going to be the main method we use for having objects control other objects. And hopefully that all made sense. By the way, with constraint nodes, if you make one and you realize that it was a mistake, when I select this joint here, I can open it up and I can actually select my constraint object and delete it. That will unmake the connection between the control and the joint. Yes, I can also select the parent constraint node here in the node editor and delete it, but you'll see when I get to the next part of the exercise that I am not going to be using the node editor. So you can do that through the outliner too. Okay, let me know if that made sense to you, and whenever you're ready, move on to the next video and we will start setting up some controls.